What's the story behind this taillight component?
This was a applique being vibration welded upper and lower lens to the housing. We quoted on making a vibration weld tooling to weld the upper to the lower. Built the tooling to customer specs. I had CMM checked. Everything was good within spec. The issue came to light when the parts came in. Pretty well out of control warpage on these parts. We could weld parts all day. That wasn't an issue. We could weld parts. Couldn't get a repeatable part. You've got to have these parts welded down, and they've got to meet body lines around the lens, and that was where the issue had come in. There's areas on that part where you could have put some tabs, we could have put some grippers, pulled it down. Once we can pull it down into the nest consistently, then the part tends to weld better and you get a more repeatable part. We had to grip on some of the features that were there, but they weren't in the most ideal position. We grabbed on some of the ones that are to the outer section of the can. The intersection would have been better because the part warped more like a potato chip. It always tends to want to warp in the direction that it's curved. We were able to accomplish it, but it was more a costly process to do it. It wasn't necessarily the best situation, but we were able to make it work.
What's something customers can do to minimize risk? What's the learning experience here?
The lesson learned on this is to really communicate down the chain. The molder, the tool builder of the vibration weld tooling should all be working together to understand the process, start to finish. A lot of times the assembly process hasn't even been figured out while we're building the fixture, and even sometimes when the fixture is complete. Save yourself a lot of grief, a lot of aggravation if you communicate what intent is. And generally, we're just given two parts to weld together. Okay, we make a fixture to weld these two parts together. We have to make assumptions. They are going to be within tolerance. So if you start that discussion up front, start saying, what are these potential problems that we've seen in the past? I can't say from one to another part the issue is going to be the same, but we've seen enough parts over the years we can get a pretty good idea of what's going to happen and what we can do to give us a better chance at a better outcome. The other thing we find with a lot of these fixtures is the initial samples are run and fit to pre-production parts. So that's the first issue. The second issue that comes up is the part shrink issues during summer or the winter. The plants aren't climate controlled. We've seen issues on these parts where the lenses, they shrink more or less in the summer or the winter. They start giving them problems. You know, the basics behind vibration welding is holding the parts steady in the fixture. They have to be held solid. And if you start getting a shrink issue or the part shrink more, now the part has the ability to move in the nest and your weld is not as good. So you start, besides having repeatability problems because your part shrink changed, you also don't get as good of a weld. Now you start having leakage issues and you start rejecting more parts. So all of these things have to be thought about ahead of time as to what could you do on this fixture to accommodate all these processes.